we are going to talk about the petroleum system. We are going to look at an introduction to the petroleum system, as well as the elements that makes up the petroleum system. And when we talk about the petroleum system, we can think of it as cooking. Let's say you want to prepare soup. There are some key ingredients that you need so that they will all come together to make the soup. And what happens when you forget to add salt to the soup? Definitely, it's not going to taste as you would want it to. I will talk about the petroleum system. It also talks about all the elements that comes together so that we will be able to get the hydrocarbon, that is the oil and gas that we want. And should it happen that one of these elements is left out, we are not going to get the hydrocarbon that we need. And so all the key elements that comes together is what you call the petroleum system. And so the petroleum system is basically a complete geological system that explains how hydrocarbons are generated, how they migrate, how they accumulate and are preserved in the subsurface. Now, what are some of these key elements that we're talking about? And one of it is what we call the source rock. Other elements include the reservoir rock, a sieve, and a trap system. We have migration and also accumulation of hydrocarbon. It is these elements that comes together so that we will be able to have what we call a petroleum system and also the generation of hydrocarbon. Each of these elements is very important, and that's why we refer to it as complete geological system. Because if one of it is missing, we wouldn't have the generation and accumulation of hydrocarbon. Now let's look at these key elements one after the other. Let's start with the source rock. Now when we talk about a source rock, one will wonder, why would we have an image of a kitchen when we're talking about a source rock? Now the food that we eat in the house, where do we get it from? It is from the kitchen that all the ingredients are being put together to prepare the food that we eat in the house. And just as the kitchen serves this role, the source rock also serves as a kitchen when it comes to the generation of hydrocarbon. And it is the source rock where oil and gas is being created. Now, what does a source rock look like? Now, source rock are basically sedimentary rocks. And these sedimentary rocks, we can think of the shale. Also, we have mudstone, and sometimes limestones also form very good source rocks. Now, we compared source rocks to the kitchen and also cooking. And so, what are the ingredients that need to be present in a source rock in order for it to create or generate hydrocarbon? Now, one of the ingredients we need is what we call an organic matter. Now, when we talk about organic matter, we can think of plants, animals, algae, and plankton. Now, it is these elements that a source rock needs in order for it to generate hydrocarbon. Now, source rock gets these elements as a result of what we call sedimentation. Now, these plants, algae, and plankton are being carried by water to the desired areas where they accumulate for the source rock to be formed and also for hydrocarbon or oil and gas to be created. And one other very important element that a source rock needs is a low oxygen environment, what we call the anoxic environment. That is an environment that has very low content or amount of oxygen. Now the reason why that is important is because oxygen aids deposition or decomposition, and we don't want this organic matter to decompose. We want them to be preserved, and so for that to happen, the area or the environment should have very low oxygen content to prevent decomposition of our organic matter. An environment that has this condition is swamps, the deep sea, and also lakes. And so when all these ingredients come together, then we have the generation of hydrocarbon. Also, one other element that we need is temperature. We all know in order for you to cook, you need heat. And so heat is one of the key elements that should be present in the source rock to aid the generation of hydrocarbon. We also need pressures as well. Now, what other elements are there in the petroleum system? Well, another element is what we call the reservoir rock. Now, the reservoir rock is a subsurface body of rock that has sufficient porosity and permeability to store and transmit fluids. Now, we'll talk about a reservoir rock. We can think of something like a foam. Now, we know foam has these tiny holes in it so that when you pour fluids inside, it has the ability to accumulate some of these fluids. Now, because of these holes, it also allows the fluids to flow from one point to another. And so, a reservoir rock mimics the behavior of a foam. It has sufficient porosity, that is, small pores that allow the accumulation and storage of hydrocarbon. Now, these same holes also allow these hydrocarbons to flow from one point to another. I will talk about a source rock. We'll talk about a reservoir rock. A typical example is a sandstone. Now, sandstones have sufficient porosity and permeability that allows them to store fluids and also allow transmission of these fluids. Now, common rocks that make very good reservoir rock, we've already mentioned one, that is a sandstone. Other example includes what we call a limestone and also dolomite. Now, all these things have two things in common. They have sufficient porosity, that is enough space to allow hydrocarbons to be stored, and also they have sufficient permeability, that is, they allow these fluids to flow from one point to another. Another element that we're going to look at is what we call a seal rock. Now, what seal rock basically does is that they stop the hydrocarbons from escaping. So they prevent hydrocarbons from leaking out of the reservoir. Now, earlier we mentioned that reservoir rocks are permeable and porous. That is, they allow fluids to be stored. Also, they allow these fluids to move or to flow from one point to another. Which means if you don't stop these fluids, they'll just keep flowing out of your reservoir. And so the element that prevents these fluids from flowing out of the reservoir is what we call the seal system. Now, if you look at the image, that is a typical example of a seal. Now, seals are impermeable. What this means is that they don't allow fluids to flow through them. And so when the fluids flow to the reservoir, these seals, because they are impermeable, they prevent these fluids from flowing further out of the reservoir. Now, a typical example of seal rocks is what we call shale. Now, shale make very good source rocks because they are porous, that is, they have enough space, but they are impermeable, that is, they don't allow these fluids to flow out of them. And for that reason, they make very good seal rocks. Now, what about salt? Well, salt dome, when are formed in between reservoir rocks, also are able to serve as seals that prevent further migration of these hydrocarbons. And hydrides also are very good examples of seal rocks. So the next thing we're going to look at is what we call the trap system. When we talk about traps, we can think of it as bottle top. I realize that when you have water in your bottle and you don't close it, what happens? Eventually, the water flows out of it. Of course, you have the surrounding part, that is the seal. Yes, you need the top to prevent your fluids from getting out of your bottle. But it is the same for a petroleum system. But what traps does is that they are geological configuration which holds the hydrocarbon in place. They are the ones which make sure that these hydrocarbons are being stored and also accumulate in huge quantities for it to be economically viable. That is, for us to get enough oil to sell and earn profit. We'll talk about traps. We have two types of trap. We have what we call the structural traps and also the stratigraphic traps. But the difference between these two, when we talk about structural traps, for them they are formed by deformation of rock layers. So the rocks is deformed to form what we call the structural trap system. Well, an example of this is what we call the anticline. We also have other examples such as salt domes and also faults. I will talk about stratigraphic traps. For them, they are not formed as a result of deformation. Rather, they are formed as a result of change in rock type. And so you have a continuous layer of a particular type of rock, but at some point, the type of rock changes. So maybe you had a permeable rock from one point to another, but it gets to a point where it changes to an impermeable rock, ending up to form what we call a trap system. An example of it is what we call a pinch out. And also we have unconformities also as part of stratigraphic traps and also reefs. If you look at the image, you can see the two different types of structural traps that we have. Now we have what we call the anticline. Now an anticline is basically a formation that has been bent because of compression. And so you have a formation that bends to form an anticline. And anticlines make very good traps. We also have what we call faults. Sometimes because of tectonic activity such as an earthquake, you have a formation being divided into two. One ends up facing an impermeable layer, so ends up preventing the hydrocarbon to further escape out of the permeable zone. So these trap systems are very important because they are the ones which helps the accumulation of hydrocarbons in one place. Well, one element that is very important when it comes to hydrocarbon generation is what we call pressure. Now, ideally, hydrocarbons are being found in very deep formations. But before we get to this deep formation, we have a lot of rocks that are being placed on top of it. And so it's like when you place a person down and you put 10 people on it, you realize that the person is going to experience a lot of pressure, isn't it? And so because these hydrocarbons are found, or these source rocks are found in very deep formation, it experience what we call overburden pressure. And this pressure is what aids in the generation of hydrocarbon. Now, this pressure overburden rocks play a very key role. One of the things that they do is what we call it provides pressure. Like I said, pressure is needed for this ingredient, that is the organic matter, to be changed into oil and gas. And so it is the role of these overburden rocks to provide this pressure that we need in order for us to generate hydrocarbon. Now, one thing about pressure and temperature is that they are related. As pressure increases, temperature also ends up increasing. And so the deeper you go, the hotter it becomes. And so this overburden rock also help increase pressure, and as a result leads to the increase of temperature, which is a very key element when it comes to the manufacturing or the cooking of organic matter into hydrocarbon. Now, like I said earlier, it is this pressure and temperature that enables hydrocarbon to be generated. But another thing that is important is what we call generation and expulsion. Now, what is generation? Well, when we talk about generation, it is a point where organic matter is being transformed into kerogen. Now, you might ask, what is kerogen? Well, we need this key element, that's organic matter, to form hydrocarbon. And when we get this organic matter, that is remains of plants, animals, algae, plankton, with increase in pressure and temperature, this organic matter is being converted into what we call kerogen. And so this kerogen is the initial ingredient that we need for the hydrocarbon to be generated. And kerogen eventually cracks to form oil and gas when pressure and temperature increases. And if you look at the image, you realize that as temperature is increasing, our organic matter changes into what we call kerogen. Now, with the subsequent increase in temperature, another process is what we call the diagenesis. Now, this kerogen is further broken down with increase in temperature to form what we call methane gas. Now, as you keep increasing this temperature and pressure, this kerogen keeps on breaking into further elements Now, as temperature increases to somewhere around 60 degrees Celsius, we have this kerosene being transformed into oil. That is what we call the crude oil. Now, if you keep increasing this temperature to as much as 120 degrees, you're going to have this oil being changed into gas. So you realize that this process is very important for hydrocarbons to be formed. That is, it starts from a kerosene. That's when organic matter is being, when organic matter meets temperature and pressure, it changes to what we call a kerosene. That is an insoluble substance. Now, when you keep increasing the temperature, kerosene now changes into what we call oil. And when they keep increasing the temperature, it changes to what we call gas. And so ending up forming the oil and gas that we know. Now, this happens in a source rock. And like we said, source rocks are very impermeable. And what this means is that if you have your hydrocarbon in a source rock, you cannot produce from it because you're not going to allow these fluids to flow from one point to another for you to produce it from subsurface to surface. And so they need to be expelled from the source rock to what we call a reservoir rock. Now, reservoir rocks are permeable, that is, they allow these fluids to flow. And this process is what we call the expulsion. That is, the hydrocarbons are being squeezed out of the source rock. Now, this happens because the source rocks have very low permeability. Like I said, they do not allow these fluids to flow from one point to another. And so the fluids have to be expelled from the source rock to a reservoir rock. Now, this is the first movement that the hydrocarbon experience, the movement from the source rock to the reservoir rock. Now, this movement from the source rock to the reservoir rock is what we call migration. So when we talk about migration, the hydrocarbon, that is oil and gas, that has been generated in the source rock moves from the source rock to the reservoir rock. And we have two types of migration. We have what we call the primary migration and the secondary migration. I'll talk about the primary migration. It's just migration from the source rock to a nearby carrier bed. And so the source rock have other formation closer to it. And because of increase in pressure, eventually these hydrocarbons moves out of the source rock to a nearby formation. And so this movement, this first movement, is what we call the primary migration. You can think about it as maybe you're cooking in the kitchen, you have oil spilling. The oil would move around the kitchen. It's not going to go any further. So that initial movement is what we call primary migration. I also have what we call the secondary migration. The secondary migration, it moves further away. Supposing this oil now start moving from the kitchen up to your bedroom, you realize that that's quite a distance, isn't it? And so this long movement is what we call the secondary migration. And this happens through permeable rocks. And so when it gets to the reservoir rocks, it keeps moving until it encounters a trap. And this movement from the source rock to a far away reservoir rock is what we call the secondary migration. Now, what causes these hydrocarbons to move? Well, these hydrocarbons is what we call their less dense. Now, what this means is when you compare the weight of water to the weight of this oil, water is heavier than oil or denser than oil. And so it causes this hydrocarbon to be expelled out of the reservoir of the source rock to the reservoir rock. Now, one other thing has to do with buoyancy. Now, we'll talk about buoyancy. You can think of it as, you see, when you pour oil on top of water, realize that always the oil is going to be on top of the water. Why? Because water is very heavy or denser than oil. So for that reason, oil would always come on top of water. So because of this same process, it causes these hydrocarbons to move into the reservoir rock. Now when it gets to the reservoir and then there is water inside, because water is heavier than oil, you realize that the oil will come on top of the water. And so that is basically what buoyancy means. I'll talk about accumulation. Now, when the oil or the hydrocarbon gets to the reservoir, it's going to keep moving until it meets a trap. And when it meets a trap and a seal, the hydrocarbon will keep accumulating. And so, for oil and gas to stop migrating, they have to meet a trap and also a competent seal. If the seal fails, you're going to lose your hydrocarbon because they're going to keep migrating into further formations. Well, we've talked about a lot of elements, but time is a key factor. Why do we say this? Well, supposing that the hydrocarbon is generated from the source rock, now it's matured and it starts moving out of the source rock. I guess to the reservoir rock, but the reservoir doesn't have any seal or any trap. What happens? Your hydrocarbon is going to escape the reservoir. And so you realize that time is very important. And so if traps are formed after migration, the hydrocarbons are going to escape. And so for hydrocarbons to be accumulated, the trap are supposed to be formed before the migration of this hydrocarbon. One other thing is that you can have your seal breaking because of tectonic activities. It could be earthquake, it could be human activities that will cause the seal. That is what is preventing the hydrocarbons to migrate to break, causing these hydrocarbons to leak. So realize that time is a very good factor. It is a time that makes hydrocarbon accumulate. If one of these elements is not present at the right time, you're not going to have accumulation of your hydrocarbon. So time analysis is a very critical part of exploration. And so when the timing is right, and you have all these elements together, a trap, a seal, a reservoir, your migration and accumulation, then you can have what you call a complete petroleum system. But why does petroleum system matter? Well, understanding petroleum system really helps engineers, that is petroleum engineers and also geoscientists. But why do we say this? Well, it helps us to predict where oil and gas may be found. And so when you find a source rock, then there is a possibility of having a reservoir somewhere around. And so it would enable you or would help you when it comes to your exploration process. And so when you find a reservoir rock too, then it means that somewhere nearby there is a source rock. So when you find all the two, it really helps you to be certain that there is a potential of you discovering hydrocarbon in that area. Now, exploration is very risky. For one thing, it is very costly. It requires a lot of money to undergo exploration process. Seismic survey, drilling of wells costs a lot of money. Now, in order for you to reduce this risk, you have to get a very good understanding of your petroleum system. If you have a source rock, you have a reservoir rock, and you know your trap system, you have a higher chance of succeeding when you drill a well. If you don't have these things, your chances of succeeding in your exploration is very low. And so when you have a very good understanding of this petroleum system, it really help you to reduce the risk of exploration. I also help us to understand a dry well. Well, what is a dry well? Well, as petroleum engineers, sometimes we drill a well to find hydrocarbon. But after drilling, you realize that you couldn't find oil. So when you drill a well and the well doesn't find or doesn't hit any oil, then you say you found a dry well. But when you find a dry well, if you have very good understanding of your petroleum system, it will help you to see that you haven't failed, but rather maybe you just drilled at the wrong place or the seal that was found in that reservoir failed at some point. So you can go ahead to drill another place. It also give you data to go ahead with your exploration. And so when you have a better understanding of petroleum system in your exploration, it really helps you to minimize some of this risk. But it also helps to design a better development strategy. Well, why do we say this? If you know where your source rock is and where your reservoir rocks is, it helps you to better know where to drill. It also helps you to know what type of seal do I have, at what pressure do I do my analysis so that I don't fracture this seal. So in order for you to better develop your field, you need a better understanding of your reservoir system or your petroleum system. So that is all for a petroleum system. Please, if you're done watching this video, subscribe and also like. And please Share the link for others to have access to the video. At this point, you can pause the video and answer these three questions. Please do well to leave your answers in the comment section.